This video is for our Module 15 and 16 review. So it's going to go over some problems that are very similar to the ones that we will see on our test tomorrow. So make sure you follow along, make sure you know how to do each of these different types of problems. So we're going to start with measures of center. So these are things that are going to tell us kind of the middle of our data. So when we are finding the mean, we want to take all of the numbers, we want to add them up, and then we divide by how many numbers we counted or how many numbers we added up or part of the data set. So that kind of fair shares or makes an average of everything, kind of, right? If we all pick different amounts of apples and then we all put them in a basket and divided them out equally, that is our average there. So the median, it's very important that we put them in order, least to greatest, and then we find the middle number. So this is often a pretty good indicator of, these two are usually good indicators of the center, kind of dividing everything out equally or finding that middle number. And then our mode is the one that happens the most often. And sometimes that can be a good indicator of the data. But if you have one number that maybe does have more and it's at the end, that's maybe not a good representation of all the numbers. So it's just important to kind of look at and analyze your data of what numbers do I have, what number best represents them. So this table shows the weight of boxes on a postal truck. So we want to find the mean of the boxes. So go ahead and add these up. So here I can see 10 and 10 is 20, 24. And here is 8 more is 32. Plus 12 is 44. 5 more is 49. 9 more, so what did I say? 49, and then 9 more is 58. So we have 58 pounds in boxes, and I have 8 numbers that we added up, so we're going to divide that by 8. And I know that 8 doesn't go into 58 evenly, so I'm just going to go ahead and add that decimal to get started. So it goes in there 7 times is 56. There's 2 left over. It goes in there 2 times is 16. 4 left over, bring down another 0, and 5. So if they evenly distributed the boxes and rearranged them, they would each have 7.25 or 7.25 pounds in them. So here we have this bus driver is counting the number of passengers at each bus stop that get on the bus. And so here are there 5 different bus stops and how many passengers got on. So we're going to find the mean, the median, and the mode. Since we're looking at all of that data, let's go ahead and put these in order. So go ahead and do that. So 8, 8, 10, 11, 13. So to find the mean, we want to add these all up. So here's 16 plus 10 is 26, 11 more is 27, and 13 makes 40 divided by 5. I am not quite sure I did that right. So I'm going to double check myself one more time. 8 and 8 is 16, 10 more is 26, 11 more is 37, and 13 more. Oh yeah, I forgot to carry that 1 up. I was like, just didn't feel like 8. I was like, 8's too little. It's got to be more in the middle. So I forgot to carry my 1 in my head. So good thing I double checked myself. So it's really 50 divided by 5 is 10. Okay, so that sounds a little bit better, right? I knew these were too little. It had to be more in the middle because I had these bigger numbers that needed to pull it over. Okay, the median, find the middle number, is also 10. And the number that occurs the most is 8. So if I had to choose one of these data points to represent them, I would choose the mean or the median because they're the same, and that's the very center of my data, and it kind of represents everybody. So yeah, sometimes if you less got on, sometimes if you more, but overall, about 10 people were getting on the bus every time. So this mode, yeah, it occurred the most often, but there's also 3 other numbers that are bigger than that. So I don't really feel like this is a good representation, but either of these would be a good representation of that data. Hey, George works with his dad in a yard to help get ready for a new patio. The times in minutes he works each day are listed. What is the mean of these times? So our average, we want to go ahead and add these all up. So I'm not going to try and do these ones in my head because I know I won't be able to keep track of them. So I'm going to just start with these 3. So here's 12 and 5 is 17. Here's 5 and 10. So there's 137. So now I've got 65, 30, 46, and 51. So here is 11 and 12. Here's 9, 10, and 9 more is 19. So 192 and 137. That way I just didn't have as many numbers to keep track of. So here is 9, 12, and 3. So all of the minutes he spent was 329 helping his dad. So if he took those and kind of spread them out equally, and he would have helped his dad the same amount each day. So he helped his dad 1, 2, 3, 4, 5, 6, 7 days. So go ahead and do 329 divided by 7, and that will give you the average amount of time he helped his dad work in the yard. Hey, for a beach trip, Marion spent $9 on sunscreen, $18 on beach towels, 22 on food, 9 on a first aid kit, and 11 on sand toys. So what measure of centers, that's the mean, median, and mode, is represented by 9? So I'm going to put these numbers in order so I can kind of look at them a little bit better. So I've got 9 on sunscreen, 9 on a first aid kit. I've got 11 on sand toys, 18 on beach towels, and 22 on food. So it's not the median because the median is 11. It does happen multiple times, so it could be the mode. And I know it's not going to be the average because 9 is over on this far end. It's really not in the center of the data. And I've got these 9s and 22s. And I know somewhere between 9 and 22 is not going to be 9. It's going to be somewhere around maybe like 16-ish, about 5 more. So 16 and a half, somewhere in the middle. If I'm looking at highs and lows, right, they've got to meet in that middle area somewhere. 9 and 22, the middle of that is not 9. So I think it is the mode. So for a beach trip, so same problem. He spent this on his sand toys. What is the median? And we've already put them in order. So we know our median is 11 here. And then our last problem asks which measure of center will help determine the average cost of the items. Well, the average is another word for mean. So that is the measure of center that he would use to find the average. And it doesn't even ask what is the average. It just says which one would help him. Hey, let's check out our dot plot here. So what is the mean, median, and mode? So when we're doing these dot plots, we've got to think about it a little bit more. And I really think it's best to just list out the numbers. And then you don't even have to worry about trying to use your dot plot because it can be a little more complicated. So I'm going to start and I'm going to list out these numbers. So I have 15, 15, and I have a 16, 2 17s, 3 18s. Oh, I don't want to write it quite that close to each other. It looks like 181. And then I have 2 20s. So we can find the mode, and that one is a really nice one to look at the dot plot. And I can also see there's 3 of these here, and this is the peak here. So the mode is 18. So now we want to find the median. So 15 and 20 match, 15 and 20 match, 16 and 18, 17 and 18. So now I'm left with these two in the middle here. So I have 1, 2, 3, 4, 1, 2, 3, 4 on each side. So the middle of 17 and 18 is 17.5. So now we need to find that average. So we want to add all of these up. So here I can see here's 30, 16, 17, and 17 makes 34. Oh, let's see, 18. Oh, okay, let's see. Just going to start with this so far. So I've done 15 through 17. So there's 10 and 6, 7, 8. Okay, now I have my 3 18s. So I'm going to just do 18 times 3 is 24. And 3, 4, 5. So there's 54. And 2 20s makes 40. So I've got 80, 40, and 54 as my total pieces here. So here's 4. 12 plus 5 is 17. So I have a total of 174. And then we're dividing by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I know it's not going to go in there evenly because it doesn't end in 0. So I'm just going to go ahead and stick that 0 at the end there. And now it will have one decimal place. So go ahead and figure out that mode there. Okay, we're going to move on to our measures of variability. So the range is when we take let me get my mouse here, big, and we subtract the littlest amount. Okay, so it's telling us overall how the data is spread out. So bigger number is going to be a bigger spread, smaller numbers, smaller spread. So to do the IQR, we take the upper quartile and we subtract the lower quartile. Oops. Okay. All right, when we make a box plot, we first put the numbers in order, and then we find the median. So I'm just going to kind of draw, right? So this is the median. Then I mark Q1. So then I mark Q3. So those all go make my boxes. And then I draw my whiskers to the smallest point and the biggest. So this is the minimum. This is the max. Okay, to find our mean average deviation. So we've got 3 steps that it takes to do the math. So 1, find the mean. 2, remember we find the distances to the mean. And then 3, we find the mean of the distances. So 3 steps, find the average. Tell me how far away they are from the average. Then I find the average of the distances. So that is MAD right there, mean absolute deviation. To find Q1 is, I'm going to type here. So to find Q1, first we have to find the median. Then we find the middle of the first half. Kind of overlap there, that's okay. And then to find Q3, or the upper quartile, we start with the median still, and then we find the middle of the upper, or the second half of the data. So then we just split our data into 4 equal sections, and then we can see where are the numbers concentrated in this box plot. So that helps us draw this box plot. We can see, right, this is closer together. So we've got more numbers packed in that area, where when they're more spread out here, we don't have as much data in that. It takes up a bigger amount of space. It's more spread out, not as consistent. So this tells us that 8 chickens on a farm are weighed. Their weights are listed here. So we need to find the mean and the mean absolute deviations of these weights. So 3 steps: find the mean, find the distances, find the mean of the distances. So let's start here and add these up. So go ahead and add those up, line up their decimals, and come back when you are ready to check. So I'm just finishing listing these here, 5.9, 6.2, and 5.7. All right. So, excuse me. Okay, I can see 10 here, and 10 here is 20. 8 and 2 makes 30, 37, 38. So I always like to look for those compatible numbers, just kind of mark off that I actually use them to make sure I have everything. All right, so here I can see, I'm going to switch colors here. 5 and 5 is 10, 15, 20, and 26, 32. 6 more is 38. And 10 makes 48. Bring down that decimal. So the total amount of the chicken eggs is 48.8. And then we're dividing by how many eggs we had. 1, 2, 3, 4, 5, 6, 7, 8. So 48 goes into, divided by 8 is 6. And 8 goes into 8 one time. So the average amount of a chicken egg for these 8 chickens was 6.1 pounds. So now I'm going to make a list of how far away these are. So to get from 5.8 to 6.1 is 0.3. So I'm just going to list them out so I can add them up. This is 0. I'm just going to put that in there so I remember I still have that as a distance. So 0.5 all the way up to 0.61 is 0.6. 6.5 to 6.1 is 0.4. 7.1 to 6 is a whole pound different. 5.9 to 6.1 is 2/10. 6.2 to 0.1 is 1/10 different. And 5.7 up to 6.1 is 0.4. So now we are finding the average of these distances. So you really want to make that list because you've got to know those distances and keep track of them. So it's just easiest to write them down as you go. So here is 10, 13, 14, 15, 16, plus 4 is 20. My decimal comes straight down. 2 plus 1 is 3. So this mean absolute deviation, oh, I did not divide. I was like, 3? That can't be right. Like they're all pretty close to each other. They're not even 3 pounds apart. So I've got to take that is what they all the differences weighed together and divide by 8 again here. So can't go into 3, but it can go into 33 times, which is 24, and bring down that. 8 goes into 60, 7 times is 56, and bring down a 4. 8 goes into 40, 5 times. So our average was 6.1. So most of the eggs weighed 6.1. Not most of them. The average of the eggs weighed 6.1 pounds. All right, if we redistributed them and made them all the same, they'd be 6.1. The deviation then is 3.375. So that's like 37 cents. That's really not a lot of money, and it's not a lot of deviation. That's a really small amount that these eggs are deviating. So they're all pretty consistent that these, oh, I keep calling these eggs. Then I was like, what kind of chicken is laying like a gigantic 7-pound egg? These are not eggs. These are literally just chickens. I'm so sorry. Probably wondering what I was talking about. So these 8 chickens are pretty consistent that they weigh about 6 pounds, right? There's like this one that's a little bit more and maybe one that's a little bit less. But overall, they're about 6 pounds because this is a really small number. It's less than 1. It's less than a half. So it's a very close and consistent, right? All their chickens are getting the same amount of food and really thriving. There's no one chicken that's really dominating and taking those resources from another one. Sorry, I was really like, gosh, these are really giant eggs. I was like, maybe they like weighed all the eggs that that chicken laid together or something. So that makes more sense. Those chickens would weigh on average 6.1 with a mad deviation of 0.375, which is very small. So the chickens are very consistent around 6 pounds. Okay, so let's look at this histogram and decide which best describes our data here. So we can see our weekly hours of practice anywhere from 1 up to 20 hours of practice for those violin students. Okay, so a peak at 13 to 16. So that is not the highest point. So no. There's an outlier from 0 and 10. I don't I don't think that's an outlier. They pretty consistently, right? There's students that practiced at every interval there. There is a cluster from 13 to 20. So yeah, there is, but there's also not really a gap here. So I would say the cluster is the entire thing. So there's not a cluster there particularly. And the data is approximately or close to symmetric, right? If I cut this in half, right? This goes up, this goes down. It's pretty close to symmetric. So it is almost symmetric. All right, looking at this dot plot, suppose one more data point is added to the plot at 19. So let's go ahead and add that there. Which statement best describes how this would change the measures of center? So I think we need to find them first and kind of look and see. So we had 15, 15, 16, 17, 17. Oh, these are the same ones that we used before, I believe, right? We found these earlier. So let's go back and pull that data where this problem here, right? We already found that the mean was, so it was this 174 into 10. So this goes in here one time, which is 10, 7 left over, 74, 7. Then we've got 4 left over and 4. So our mean was 17.4. Whoops, 17.4. So let me just copy this and come back to our problem here because we already did this, so we don't need to do it again. Okay, so we know this is what it was to start. Okay, so now we're adding in another number 19 right here. So we need to see how are the measures of center going to change. So did the mode change? No, the most occurring number is still 18. So that stayed the same. My median, let's see. So I added a number here. It could shift it a little bit bigger depending on how the numbers fall. So we had 15 to 20, 15 to 20, 16 to 19, 17, 18, 17, 18. So it did shift it up just a tiny bit. And so we had 174 and we're adding on 19 and we've got 13, 7, 8, 9. So now we've got 193 and we're dividing by 11. So let's see how that changes here. So 11 goes into 19. My mind went blank. That is one time. So we have 8 left over, goes into 83 7 times. So we're still about 17. So I might just bump it up a tiny bit more. So maybe it'll be about 7.5 now. So goes in there 77. So we've got 6 left over. So I'm going to add this decimal. Goes into 65 times, which is 55. And it's just going to keep going for a little while. So it's about 17.5. So it really didn't change the mean that much. It barely shifted the median because that's a number that's pretty close in here. If we would have added a point at like 40, that really would have shifted everything bigger, except for the mode would have stayed the same. But those other numbers would have shifted over because it had to incorporate that number far over. But where this was right kind of in the middle of them, it didn't really change things. So the median is the only measure that would change. So it changed a little, the mean changed a little. So I'm not going to just cross that one off. It's okay. The measures of center would be unchanged. Well, no, they changed a little bit. The only measure of center that would change is the mean. Well, that wasn't true. And the median wasn't the only one. So the mean and the median both increased. So they didn't increase a ton, but they did increase a little bit. So as we're doing these, we kind of need to know what were the data points to begin with? What did they change to? If I'm adding numbers that are bigger, it's probably going to shift them up. If I'm adding numbers that are smaller, it could shift it down. And the median is just going to kind of depend, right? If our median would have been an 18 to start, if we had one fewer 17, then it probably wouldn't have shifted because we have so many 18s. But so you just kind of have to do some work. You can do it. What was it to start? What was it to end? Okay, 8 stores at the mall sell the same style of pants for these different prices. What is the median? So we want to go ahead and put those in order. And so we've got, so go ahead and do that. 32, 35, 36, 37, 38, and then we've got 40. I'm going to be in the way here. And then we've got 42 and 44. So if they have my size in stock, I'm definitely going to want to go to this cheapest store here because they're the same exact pants. So find our median is finding that middle number. And we've got 2 in the middle here. So the middle of that is $37.50. So the pants are around $37.50 at any given store. So now we're going to find the lower quartile. So since we had 2 of these here, we've got to split them and give the 37 to the lower quartile and 38 to the upper quartile. So now finding the lower quartile, we've got the middle here is $35.50. And then the upper quartile, got these here, the middle of those are $41. So if I was drawing that box plot, I'd have $37.50, $35.50, $41. Draw those out. It goes down to $32, goes up to $44. So I can see the most right, they're pretty commonly around $36. And then there it kind of goes up a little bit. So not as many of the pants are as expensive. Most of them are around that $36 mark. Hey, we've got this dot plot here. So we need to find the mean. So we're adding these up. So here is 2 and 6. So I got 6 because this dot is worth 3 and this dot is worth 3. So then 4, 8, 12. And then we've got 5, 10, 15, 20. I should really be writing these up and down. That's going to be a lot easier. And 20, 6, 12, 18, 7, 14, and 8. So adding these up, we've got 2 and 4 plus 6 is 10. 8 and 8 is 16. So 26 plus 4 is 30. We've got 3, 4, 5, 6, 7, 8. Now we've got to divide by all of the dots, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 dots. So 16, 32, 48. Let's see, 16 more plus 48 is 50. Nope, 64. I was like, that's not enough. 64. And then what am I adding on? 16 makes, 80. Perfect. It goes in there exactly 5 times. So my mean is 5. So now I'm going to list out the distances. So to get from 2 to 5 is 3. To get from 3 to 5 is 2, but I have 2 of those, right? Each dot is 2 away. To get from 4 is 1, 1, 1. And then all of these are 0 because they are the mean. The 6s are all 1 away. The 7s are 2 away, right? Because my average is 5. And then 8 is 3 away. So now I'm going to add these up. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15, 17 plus 3 is 20 divided by 16 dots still. So we're still, even though these are 0 away, they're still part of the data set. So 20 divided by 16. So this goes in here one time. And we've got 4 left over. 16 goes into 40 2 times. 16 times 2 is 32. Then we've got 8 left over, bring down a 0, and we know that 16 goes into 85 times. So our mean absolute deviation is 1.25. So our next thing wants to know which of these measures fall within that mean absolute deviation. So we add them up. So we add the mean and the mad, and we subtract the mean and the mad. So 5 plus 1.25 is 6.25. So anything smaller than 6.25 is within that normal range. And then subtracting this is 3.75. So anything between these. So 3 is too small. So these 4s fit inside of the normal. All the 5s do, and all the 6s, and then the 7s are too big. So the data points of 4, 5, and 6 fit within that normal range. Okay, and then the last thing it wants us to do is find our median. So this dot here matches to this one. I'm actually going to erase some of this work here so I can actually see my dots here. So this 2 matches to the 8. 3 matches to 7, 3 matches to 7. Oh, these are perfectly symmetrical. So these match, these match, these match. So I'm going to be left with 5 in the middle. So the mean is 5, the median is 5. This data is perfectly symmetrical. And the average deviation was 1.25. So, right, they're all spread out pretty evenly here, not too far away. So 1.25 is not a huge number, not as close as that chicken one, where they were all very consistent, but still not too terrible here. Hey, we're going to use this box plot to describe the distribution. So we're selecting all of the correct answers. So remember, this is right, 25%, 50, 75, 100. Each of these are representing a quarter of the data. The closer together that section is, the more consistent it is. There's more of those types of numbers. So of the people surveyed, half own 7 to 13 pairs. So 7 to 13, right? Here's half of the data because here's 2 sections out of 4. So that sounds pretty good. Of the people surveyed, a quarter own 3 to 10. So 3 to 10. So 3 is here, 10 is here. So I can see here's one section. This is 2 sections. So this is really 2/4 of the data. People own 3 to 10 pairs. Of the people surveyed, 1/2 own 13 to 18. So 13 is here, 18 is here. This is only one section out of 4. Of the people surveyed, 1/4 own 3 to 7. So 3 to 7 is one section out of 4. So we're just seeing how many sections is that range. And of the people surveyed, 3/4 own 10 to 18. So 10 all the way to 18 is 1, 2 sections out of 4. So go ahead and choose the ones that have the matching correct sections to that range there. Hey, what is the median? That's right, our middle here. The interquartile range is Q3 minus Q1, and our range is big minus little. So usually that interquartile range is going to be a better indicator of your actual data because these are less common, right? So most people own more than this. They don't own this many. Most people own about this many. It's kind of showing that middle piece here. So the IQR is kind of a more consistent piece of data for us. And that is it. So go ahead and finish up your problems in Ed and let me know if you have any other questions before we take our test tomorrow.